All right, let's get to it. So solve for x by subtracting both sides. Make sure you print off the notes or write down everything that I write down. So the first question in the notes, we have x plus 5 equals 9. So first of all, think, what plus 5 equals 9? Well, we know the answer is 4, so we better get 4. So notice in the notes, I rewrite the question, then I do an individual operation, then I rewrite that and do an individual operation, then I rewrite that and do an individual operation. But here I'm just going to be going much quicker. So we have a plus 5. We always want to do the opposite operation to both sides of the equation. If I have a plus 5, the opposite of plus 5 is minus 5. I'm going to minus 5 from both sides. On the left-hand side of the equation, meaning on the left-hand side of the equal sign, we have a 5 minus 5 is 0. Cross it off. Therefore, x equals 9 minus 5 is 4. Now, I'm going to check my answer by rewriting the question. X plus 5 equals 9. Then I'm going to take my answer that I just got 4, very carefully substitute it with brackets back into the question for the variable that it is. Rewrite the rest of it. On the left-hand side, we have 4 plus 5 is 9. On the right-hand side is 9. Notice I work on the left-hand side on the left-hand side, on the right-hand side on the right-hand side. 9 equals 9, so back to the question, near the answer. X equals 4, check mark. Now remember, there are short forms. So, x plus 5 equals 9. Instead of subtracting 5 from both sides, we can think, if we were to subtract 5 from both sides, what would happen? Well, this would go away. On the right-hand side, we could say minus 5. Remember, it's the opposite on the right-hand side. So if you have a plus on the left-hand side, it's a minus on the right. But be careful. You really want to understand the basics. Like we learned in the last section, doing the same thing to both sides, like it's a scale. Then, once you get more familiar with it, we can start doing stuff like bring it over. But be very careful, because lots of the times, people bring it over, and they bring it over incorrectly. 9 minus 5 is 4. Check mark both ways. Okay. Next example. So we have x minus 3 equals 7. So again, remember, we're always doing the opposite operations to both sides of the equations. These English instructions are all over the notes. So the opposite of minus 3 is positive 3, so I'm going to add 3 to both sides of the equation. On the left-hand side, negative 3 plus 3 is gone. Equals 0. Therefore, we have x equals 7 plus 3. On the right-hand side is 10. Circle our answer, rewrite the question, and substitute. Check your answer. Not sometimes, all the time. Every single time you ever do a question in math, check your answer. Figure out another way to figure out how to do it. That is going to be your best teacher. So taking our x value, 10, substituting it back into the variable x, rewriting the rest of it. On the left-hand side, we have 10 minus 3 is 7. On the right-hand side, we have 7. Back to the question, x equals 10, check mark. Now remember, if you just want to check your answer in your head, feel free. X is 10, putting it back into the question, 10 minus 3 is 7, check mark. Outside of that, the short form, we have x minus 3 equals 7. On the left-hand side, we have a minus 3, so I'm going to cross it off. I'm going to bring it over to the right-hand side and perform the opposite operation. Therefore, x equals 10, our quick short form. So in the example off to the right, it's in red at the moment. So I can rewrite this question, x minus 3 equals 7. Now, what if you accidentally forget and go, oh, I remember the opposite operation to both sides. I have a plus 7 there. What's the opposite of plus 7? Minus 7. So if we accidentally minus 7 from both sides, well, on the left-hand side, we have x, and then we have negative 3 minus 7 is negative 10. Adding and subtracting numbers on the number line. On the right-hand side, we have 7 minus 7 is gone, which is 0. Now I have x minus 10 equals 0. What am I going to do? Well, I have a negative 10, so I can just do the opposite operation of both sides. Plus 10, plus 10. Therefore, x equals 10. Circle our answer. Same answer as above. Check mark. So, again, you can do anything you want in any order you want to do it. You just can't break the laws. BEDMAS is a preference, kind of like laws, but a preference of operations. There's all sorts of idiosyncrasies and all sorts of things where you don't do that. In mathematical operations, we're going to learn more in the future where we do the opposite operations to both sides, and we typically work with BEDMAS backwards. But again, that's not a 100% rule. So remember, we have a toolbox of things that we know how to do. We need to figure out how we can apply them without breaking any of the laws. Okay, next question. So we have negative x plus 2 equals 5. So here I have this negative x. We haven't seen negative x yet, but x is negative. So I have this plus 2. What do I want to do? Let's subtract 2 from both sides, performing the opposite operation of both sides. Now, 2 minus 2 is gone, 0. Now we have negative x equals 5 minus 2 is 3. Now I have negative x equals 3. Well, I can clearly see that x is negative 3, but I have a negative in front of the x, which is like negative 1. So I'm going to tuck a little negative 1 in there. It helps me out sometimes. Now it's a coefficient in front of the variable. Now we're just going to divide both sides by 1, performing the opposite operation. It was negative 1 times x, so we're just going to do the opposite operation. On the left-hand side, negative 1 over negative 1 is 1. Cross it off, and we get x equals. On the right-hand side, 3 divided by negative 1 is negative 3. Circle our answer. Rewrite the question to check our answer. Negative x plus 2 equals 5. Now, very carefully, taking negative 3, substituting it back in for x with brackets. So I'm going to put brackets around the negative 3 and the substitution for x. I'm going to carry everything else down. The negative in front, the positive 2 equals 5. Now, as we learned from before, we have two negatives side by side. I'm going to circle my two sides that are side by side. I'm going to think same plus. Negative and negative side by side is positive 3. I'm going to carry everything else down. Plus 2 equals 5. 3 plus 2 is 5. 5 equals 5. Check mark near my answer. X equals negative 3. Now, there's an alternate solution to this. So, off to the right, we have negative x plus 2 equals 5. The same question. Now, instead of minusing 2 from both sides, sure, I can minus 5, but let's not go through that rabbit hole again. We can actually add x to both sides first. So on the left-hand side, negative x plus x is 0. Cross it off. On the left-hand side, we have 2 equals 5 plus x. Now we have that 5. Now we should subtract 5 from both sides. On the left-hand side, we have 2 minus 5 is negative 3. On the right-hand side, we have 5 minus 5 is 0. Cross it off. Equals x. Circle our answer. Check mark as we got before. So remember, you can do anything you want to both sides of the equation in any order that you want to. You just can't break any of the laws. So if you want to add and subtract first, go for it. If you want to multiply and divide first, go for it. But don't break the laws. So one quick reminder here. Earlier on the right-hand side, we have 5 plus x. Now, 5 plus x is equal to 5 plus x. We cannot add and subtract unlike terms. So don't just randomly add x to something and randomly break some rule along the way. It's like apples and oranges. So be careful. So we just took a look at a bunch of adding and subtracting and a little bit of division. Now a little bit more into multiplication and division to both sides.